Laplace Transforms, Problems on Division by T Property. Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh. In the previous video, we completed two important properties of Laplace transforms. One was the right shifting or the multiplication by e raised to at property, and the other one was the multiplication by t raised to n property. If you haven't watched the video yet, then check in the description below, the link is waiting for you. So, let us rewind the topic, but before that, see, apart from being a mathematician, I am a trained psychologist and a psychotherapist. I have spent years guiding students and patients. So, every word I say, listen carefully, every word I say is carefully crafted to make you remember. So, focus on what I say, my words will settle in your brains and you will praise me after the exams. And I am serious, please no skipping. And please just do not watch. Become a part of this learning family, hit that subscribe button just like you would mark the correct answer in the examination confidently without any hesitation. Trust me, every video here is merely not just a lesson, but a mental transformation. Alright, so coming back, let us break down the division by t property of Laplace transform beautifully. So, what actually does the division by t property means? So, let us do a recap here what we have done. So, we have done this property, this first property was multiplication by e raised to at property or the shifting property, in which, listen carefully, any quotient in Laplace transform is multiplied by e raised to at, then e raised to at is not involved in the answer. What we do? The next to whatever e raised to at is there, for that we find a Laplace transform using the standard formulae. After finding the standard transform, replace all the s in the answer by s to s minus a for what? E raised to at. Okay, we use that a, that is it. The second property was the multiplication by t raised to power n property. In that, what we simply do, if any quotient in Laplace transform is multiplied by t raised to n, say t square so on into f of t, we simply find, we do not, the t raised to n we keep as it is first, the beside it what is there, that f of t, we find the Laplace of it, and after finding the Laplace, we differentiate the Laplace n times. If this t means only one time using the quotient rule, if 2 means differentiate 2 times, so on. After differentiating, multiply the answer by minus 1 raised to n. If it is 1 means obviously multiply the whole thing by minus, if it is 2 means 1 square is plus 1. So, there is no need, that is all, this is what to do. Now, similarly, the division by t property, see here, division by t property, the name itself signifies that here the quotient in Laplace transform will be divided by t. First one was e raised to 8 into f of t, second one was t raised to n into f of t. Now, the third property is what? F of t, Laplace of f of t divided by t. Any quotient in Laplace transform, if it is divided by t, say e raised to 4t by t, say cos 2t minus 3t by t, cos 2t minus cos 3t by t, say 1 minus 4t by t. So, like these questions, then what to do? So, see here, the property says, as you all know, if Laplace of f of t equals to f bar of s, then according to shifting property, Laplace of f of t upon t is equal to, see here, division by t. The question is divided by t, then use a simple relation formula, that is s to infinity Laplace of or f of t, what is that? Is nothing but f bar s ds. This is called as the division by t property. Okay. Now, in simple words, I can put like this: if any quotient in Laplace, if the quotient in Laplace transform is divided by t, okay, divided by t, then what we will do? Find the Laplace of f of t, find a Laplace of f of t and integrate it from s to infinity. So, I hope you understood this. So, what is say? Any question in Laplace transform is divided by t, then find the Laplace of f of t, that is f for s, and integrate from s to infinity. This is the what? Division by t property. I can also write this as Laplace of f of t by t whole divided by t is equal to, for you to understand, integration from s to infinity, f by s means what? Laplace of f of t, that is all. So, find a Laplace and integrate from s to infinity. Now, one more thing, you might be afraid seeing this sign, this integration sign. Okay. Obviously, integration creates fear in many people. See, it is very easy. So, what I will give? I will give everything ready made here. Whatever, see, there are basically 4 formulas required for integration. If you remember it, more than enough, and I will show you how to work easily. Okay. So, let us say the required formulas are, this is very important now. So, first one is integration of 1 by s ds is equal to log s. Then we have integration of 1 by s plus a ds is equal to log of s plus a, and one more is integration of s by s squared plus a squared ds will be 1 by 2 log of s squared plus a square, and the last one used here is integration of a by s squared plus a square ds is equal to tan inverse of s by a, that is all. So, these are the formulas of integration which will be widely used in solving the problems, and the things will be not that difficult here. I will show you the easiest way of doing it. So, please follow it carefully in the further problems. So, let us make the concept simple, crystal clear and understandable by solving some few questions. So, let us take this question here. Find the Laplace of 1 minus e raised to minus a t whole divided by t. So, see the question here. Here 1 minus e raised to minus a t divided by t. See, this is f of t, fine, upon t. So, what does it mean? F of t upon t. What is the f of t? 1 minus e raised to minus a t upon t, means the division by t property. So, what does it say? It says simply nothing but integration from s to infinity. So, we have write it here now, Laplace of, that implies Laplace of 1 minus e raised to minus a t divided by t is equal to integration from s to infinity. Remember this always, s to infinity. See, there is one more, see, if you see the video number 1, I discussed the basic formula for Laplace. It says Laplace of f of t is equal to 0 to infinity e raised to minus s t f of t dt. So, do not mistake, that is only for the general formula of Laplace, but of property the integration is from s to infinity always. What? Upon t property has a limit s to infinity, fine. So, what does say? S to infinity Laplace of what? I write here Laplace of 1 minus e raised to minus a t ds. And now, I hope you know how to solve this. So, this will be now integration from s to infinity. Do the Laplace here. What is Laplace of 1? It is 1 by s, because recall Laplace of constant a is a by s. So, 1 is 1 by s minus Laplace of e raised to a t is 1 by s minus a. So, Laplace of e raised to minus a t is 1 by s minus plus a. So, Laplace of e raised to minus a t is 1 by s plus a and into ds. Okay. So, this, okay, agreed. So, doing nothing here, what I did? Numerator whatever is there, upon t means what? Upon t has no meaning here, it is not involved here in anywhere in the answer. The meaning of upon t means the numerator whatever is there, find a Laplace from the standard formula, as you have already done it. Okay. Now, after doing that, see, I have given already formulas here. Integration 1 by s is what? Log s. So, when I integrate, the sign, integration sign goes simple. Okay. Even if you do not know that much integration, see, very simple to remember, and practice with me, you will get it. So, when I integrate, the sign goes. So, what remains? The integrated value. 1 by s integration is log s minus 1 by s plus a is log s plus a, and the limit, see, top, the sign goes and the top limit here is infinity, bottom is s. It means whatever answer I get, in that put the top, in place of s put infinity, minus in place of s put s as it is, that is it. So, how to solve this here? Now, to solve this we need some basic logarithm relations. I hope you are aware of this. Those relations are log a to b is log a plus log b, log a by b is log a minus log b, and log a raised to k is k log a. So, better I write down here. So, these are also required to solve problems. So, I write here. So, we have log of a b is equal to log of a plus log b. The other one is log of a divided by b is equal to log a minus log b, fine. And the last one required is log of a raised to k is equal to k log of a. So, these properties also you need to remember, okay, because this formulas of logarithm of properties will be useful in solving the questions. Now, here see how to apply. Now, log a minus b is what? Log a by b. Okay. So, let us write this now. So, this will be now log of s by s plus a, and limit from what? S to infinity. Okay. S to infinity. So, we have this now, fine. Now, how to solve this further? See, I can directly write, if in place of s put infinity to 0, but in examination you have to show the steps. So, what I do, where infinity is there, the simple concept is any value divided by infinity is 0. So, whenever infinity is occurring, you need to see that infinity should come in the denominator, and whenever infinity is there, we cannot solve it directly, we have to apply the limits, remember. So, I will solve this here now. So, this will be now, so log, I got log a by b. So, this will be how to solve it, we take it as limit as s tending to what? Top value is infinity, okay, log of s by s plus a. So, in first in place of s put infinity, I cannot put directly infinity, because when infinity is inward I have to apply limit here. So, limit as log of as s to infinity log of s plus minus a, minus in place of s put s only, top limit minus bottom limit, different integrals, okay. In place of s put s as it is. So, this will be as it is log of s by s plus a, fine. Now, let us solve this further. So, this will be limit of s tends to infinity. See, what I will do, I will take this as say log of s as it is, this s I will take outside bracket 1 plus a by s, fine, 1 plus a by s, okay. Now, minus log of s by s plus a as it is. Now, s cancels. Third, see, when I apply the limit here, a by infinity is 0. So, 1 upon 1, I get log 1. So, this will be what? Log 1 minus log of s by s plus a. So, what is log 1? Log 1 value is 0. Log 1 is always 0. So, this will be 0 minus this thing. So, minus log of s by s plus a. So, that means I get s by s plus a minus log of s by s plus a. Now, again, what is log a by b? Let us set a final answer here. Log of a by b is log a minus log b. So, log of s minus log of s plus a. So, again if I open a bracket, minus it minus become plus. So, we will get it as log of s plus a minus log of s. So, the final answer is again log a minus b is what? Log a by b. So, the standard answer for this is log of s plus a by s. This is the standard answer, that is all. So, you see that when I apply here the integration part, I get log s to s plus a. the answer when I apply the limits, it becomes reverse, it becomes log of s plus a by s always. So, the technique for solving the problems like this is all the same. Okay, you have to apply the same technique here, fine. So, to understand more clearly, we will do some other problems. Okay. So, let us solve one more very important exam question here. This question has been asked many times in examination. The question says, find the Laplace of cos of a t minus cos of b t divided by t. Again, if you see here, the numerator, this is what? It is f of t. Okay. So, we have again f of t whole divided by t, property number 3, that is the division by t property. So, what we do here? So, we write implies Laplace of cos a t minus cos of b t divided by t will be. So, what is the formula here? S to infinity, the Laplace of what is the numerator? Cos a t minus cos b t. So, I write directly here, as you know, what is the Laplace of cos a t? Cos a t is s by s square plus a square. So, we have s by s square plus a square minus s by s square plus b square, okay, ds. What is the next step? We need to find an integration of this now. So, this is so simple. What I did nothing, just I am putting the sign here, integration. So, I am not doing any very difficult integration here, simply I put a sign of integration here, and inside the t is not involved here. Upon t meaning is what? Simply upon t is not involved anywhere. See, upon t meaning is s to infinity, that is it, and inside the Laplace of this. The Laplace is very easy, you know, you have memorized the formula by now. So, cos of a t is s by square plus a square, cos of b t is s by square plus b square. Okay. Now, integrate is the integration formula I already given here. Integration by s by square plus a square is 1 by 2 log of s square plus a square, that is it. So, I integrate, the sign goes, so this becomes 1 by 2 log of s square plus a square minus 1 by 2 log of s square plus b square, and the limit, top limit is infinity, bottom is s. Again you need to put a top limit as infinity and bottom as s. So, it is better I show it how it is done. Now, again see 1 by 2 is outside, it is a constant, take it outside. See, what is log a minus log b? Is nothing but log a by b. It is a very simple formula or logarithmic relations, you need to compulsory remember it. Okay. Log a minus b is log a by b, or log a by b is log a minus log b. So, we have 1 by 2 is outside, so I better write it now. So, this will be 1 by 2 outside, log of s square plus a square minus log of s square plus b square, s to infinity. Now, the next step is log a minus log b, 1 by 2 outside, log of a minus log b is log of a whole divided by b. What is b? S square plus b square, and the limit from s to infinity. Now, you have to apply the limits. First, in place of s put infinity, minus in place of s put s. So, in the put s here, it will be as it is, but infinity I told you, whenever there is infinity or any value by infinity is 0. So, I have to apply the limit over that. So, I write this as limit as s tends to infinity log of s square plus a square by s square plus b square minus, say where I put the limit and bottom limit is s. So, it will be as it is. So, minus log of s square plus a square by s square plus b square. Okay. Now, let us apply the limit here. To apply the limit, you have to rewrite it. So, this will be again 1 by 2 limit as s tends to infinity log of, see what I do, I take a square outside here, 1 plus a square by a square, upon again down a square outside 1 plus a square by a square, because my concept here is to bring s down for any value by the s what is the infinity is 0. So, I get the answer here. Okay. So, I have this here, fine, and this will be as it is minus log of a square plus a square by a square plus b square, because I have put the limit s here, that is it. Now, what happens here? See, s square cancels, and when I put in place of s infinity, what infinity, any value by infinity, a square by infinity, and also sorry, this is b square, right, this is b square. Okay. So, a square by infinity and b square by infinity becomes 0. So, what remains? Log 1. What is log 1? Log 1 is 0. Remember, log 1 is 0. So, we have this as 1 by 2 0 minus log of a square plus a square by a square plus b square, fine. Now, again the same, so minus 1 by 2 outside. So, what is again log a by b? So, log a minus log b. So, log of a square plus a square minus log of a square plus b square. So, let us open a bracket again, and open the bracket, minus into minus become plus. So, plus sign will come out. So, we have 1 by 2, and this will come when I take this first, minus and minus become plus. I will take this first. So, log of a square plus b square minus log of a square plus a square. Okay. Again use the formula, log a minus b is log a by b, that is it. So, we have 1 by 2 log of a square plus b square upon a square plus a square. This is my answer, fine. This is the answer what I get. Why? Because log a minus log b is what? Log a by b. This is the answer, this is accepted. But if you still want to write in a better way, then again this is a property of log. If you want to write in standard way, if you write this answer, you will get marks, no doubt. But if you want to write in standard way, see, log a raised to k is k log a. That means k log a is log a raised to k. See, this is what? K log of whole thing a. So, what does k log a means? K log a means log a raised to k. So, if I do that, we get it as log of a square plus a square by a square plus b square whole raised to 1 by 2. Now, tell me, in the most simple form, what does raised to 1 by 2 means? X raised to 1 by 2 means root x. So, we can write this in more standard form as log of root of a square plus a square by a square plus b square. This is the standard answer required. You can write this as it is, or you can write this. That is all. I hope you understood how to solve this, but it takes practice to solve. So, please see it 2-3 times, practice it, and definitely you get the knack of how to solve it. Okay. So, let us solve one more last question to make you more perfect. Okay. So, this question has been also asked in examination. The question is, find the Laplace of 1 minus cos of a t whole divided by t. So, here see it, I am solving this taking a and b value. So, what you can do while practicing, you can change the value of a as 1, 2, 3, 4, so on, and you can do it. Okay, it will be very helpful, because in examination they can ask a question like this: find the Laplace of cos 3t minus cos 2t by 2, or Laplace of cos 1 minus cos 4t by 2 something. Okay. So, I am taking a here, so just replace the a value. So, how to do this? Again this is problem number 3. Why? Because this numerator is what? F of t upon t. Now, how to solve this? Again you need to use the third property, that is division by t formula. So, we have that implies Laplace of 1 minus cos of a t by t will be s to infinity Laplace of the numerator upon t has, listen here carefully, let us say, listen carefully, upon t, do not put it anywhere here, it has no use. The use of upon t means simply s to infinity, it is gone here. What is numerator? Take the Laplace transform, that is all. Now, Laplace of 1 is Laplace of 1 minus cos of a t into ds. So, that will be now s to infinity, Laplace of 1 is 1 by s, because Laplace of a is a by s, as you know. Laplace of cos it is s by s square plus a square, s by s square plus a square ds. Okay. Now, as you know, it is clearly given here, integration 1 by s is log s. So, we have log of s minus, what is integration of s by s square plus a square? It is 1 by 2 log s square plus a square. So, 1 by 2 log of s square plus a square, and the limit from s to infinity. Fine. So, there is here, I can apply log a minus log b, but I cannot apply here. Why? Because it is not standard. Again, see, only log a minus log b is log a by b, but here there is a obstruction, here is 1 by 2, right. I cannot apply the logarithm rule here. So, what to do? See, you know, again log a raised to k log a, k log a will be what? This is again what? K log a. So, make it log, then you will be able to solve. Okay. So, k log a, what is k log a means? Log a raised to k. So, now this will be written as log of s minus log of s square plus a square raised to 1 by 2, okay, s to infinity. Fine. So, now this looks more standard, log minus log is there. Okay. So, now again, as you know, log of something raised to 1 by 2, x raised to 1 by 2 is what? Root of x. So, raised to 1 by 2. So, I can write in a more standard way as log of s minus log of root of s square plus a square raised to 1 by and the limits are infinity to s. So, now this makes more sense. Log a minus log b is now log a by b. So, now I can write this as log of s by root of s square plus a square s to infinity. Okay. Now, as I told you, there is top limit is infinity, bottom is s. If it was any different value, I would directly apply and get the answer, but it is infinity. So, to infinity always any value by infinity is 0. So, to get that, we have to apply the limits. So, write this as limit as s tends to infinity log of s by root of s square plus a square minus, in place of s put, this is infinity, this is limit infinity, I have to find the value, and here in place of s put s as it is, that the bottom limit is s. This will be log of s by root of s square plus a square as it is. Fine. So, I apply the top limit and the bottom limit now. Now, to solve this limit. So, how can I solve this? This is again now limit as s tending to infinity log of, see the same way, s as it is I can take outside, and if I remove this outside, see s square, if s square plus a square, here in this if I remove s outside, so this will be now s square outside, s square 1 plus a square by a square, fine, minus log of s by root of s square plus a square, fine. This is what I have. Now, see, when I take this s square outside the root of s square will be s. So, I rewrite this once again. I want to solve each and every step so that you do not get confused. S tends to infinity log of s by s into root of 1 plus a square by a square minus log of s by root of s square plus a square as it is. Now, you see here this s and s cancels as usual, and what remains, s is down here. So, when I put s tends to infinity, the s value is infinity. If I put here 1 plus a square by infinity is 0. So, 1 plus 0 is 1. So, 1 by 1 log 1, again log 1 is 0. So, log 1 is 0 means we have, so we have log of 1 minus log of s by root of s square plus a square. So, log 1 is 0. So, that will be minus log of s by root of s square plus a square, fine, s square plus a square. Now again open the, again log a by b is minus log of s minus log of root of s square plus a square. Now again if I open the bracket, minus into minus becomes plus. So the log root s square plus s square comes first, simple mathematics. Okay. So this will be now log of root of x square plus a square minus log of s. So the finally the answer is log a minus log b is again log a by b. That means we have this as log of root s square plus a square whole divided by s, and this is the answer what that needs. So the final answer for this question is log of root s square plus a square by s, because log a minus log b is log a by b. That is it. I hope you understood perfectly how to solve it now. Okay. We have solved major 3 properties in Laplace transform. There is one more which is not there in the syllabus. Okay. So that is the first one was Laplace of e raised to 18 to f of t, second was multiplied by t raised to n, and third one which is solved now, division by t property, which they asked in examination. So the next video is very important, don't miss it. I will be solving mixed problems on these properties. These questions they are frequently asked in the semester examination. Okay. So if this video has helped you even a little bit, then please hit the subscribe button, comment if you have any other queries or any other doubts. The journey has just begun and the best is yet to come. Don't miss the next video. Till then, keep transforming with Laplace. Jai Hind. Bye.